So, good evening, everyone. A very warm welcome to CSEP for on today's seminar on impacting manufacturing competitiveness through smart manufacturing. We will begin by a presentation by Dr. Haresh Malkani. He's the Chief Technology Officer at Clean Energy Smart Manufacturing Innovation Institute. Dr. Malkani holds a PhD and a master's in mechanical engineering from Northwestern University. He brings over 29 years of experience in industrial research, development, and engineering in the deployment of smart manufacturing technologies, including sensing, automation, control, modeling, and simulation for the manufacturing operations. Most recently, he was the Director of Digital Manufacturing and Automation Technologies at Arconic Technology Center in the US. In addition, he has been involved with the Smart Manufacturing Leadership Coalition for over 8 years as a Vice Chairman. Then the presentation will follow by a discussion with Dr. Prerna Prabhakar. She's an associate fellow at CSEP. Her research primarily focuses on trade, industrial policies, and competitiveness. Before CSEP, she had held various positions at the Council of Energy, Environment, and Water, National Council of Applied Economic Research, Research and Information System would be to name a few among many others. Now over to Dr. Prabhakar to moderate the session. Thank you.
Thanks, Nancy. Thanks everyone for showing up for this talk. And thank you, Dr. Malkani, for agreeing to give this talk. First of all, I would begin by saying that smart manufacturing definitely is a step towards, moving towards a globally competitive production. However, we have seen in our recent CSEP working paper that India lags in terms of the research and development that it is doing, the technology adoption by the Indian industry as compared to its Asian peers. And when I talk about Asian peers, I'm not talking about China here, but then countries like Malaysia, Thailand, Vietnam, and Indonesia. So the question is that why are we not doing enough? Why is the private sector not doing enough R&D in the Indian industry? And in addition to that, there are challenges like the firm diversity in the Indian manufacturing. So we have, the segment of MSME, which is the medium, small, and micro enterprises, and the large ones. So an MSME faces the challenge to technology access, doing enough R&D, other than other challenges like access to capital, labor, and land. So these are some problems that are typical to the Indian economy and to the Indian industry. And we look forward to listening to Dr. Malkani and his experience at CESMII to inform strategies that India and Indian industry can adopt to move towards smart manufacturing. We will definitely want to understand, what's your institutional model? How do you collaborate with the industry? What's the labor challenge there, and the reach to different segments in the industry, definitely the MSME sector. So we are looking forward to the presentation. Then we'll follow it up with the discussion, and we'll open the floor to the Q&A later. Thank you. Over to you.
Well, thank you very much for that introduction. Happy to be here. I don't know what the makeup of the audience is, but hopefully we'll have an engaging discussion. I'm going to keep it at a pretty high level, not technical at all. Just to give you some background why I'm here in Delhi, I have a lot of family here in Delhi. I actually have a good friend of mine who also happens to be here in Delhi. I travel back and forth from the US to India very often. Lately, it's been once or twice a year, so I'm always happy to come back to my roots here. When I was traveling this time, I was right before I traveled, I was actually speaking to some of my colleagues who have been involved in similar fields, and they said that India's time is now. And I started asking, what does that mean? And I think in the sectors that I'm involved with, I can see already that it's not just talk, that things are actually happening. And I bumped into several people who were very, very smart. I was at the MSME day a couple of Fridays ago. I met Anup there, and the discussions there were all very, very engaging. I think the Ministry of MSME is doing some wonderful things to encourage manufacturers to do the kinds of things that we're going to be talking about here today. So exciting time for India. I'm happy to be here today to talk about this. So I'll begin with just sort of setting the stage of what smart manufacturing means, what it has done um, for some of the industry sectors in my own experience. So when I speak, I'll be speaking on, as a CTO of CESMII, but also just somebody who has had a lot of personal experience with manufacturing in my career. Um, so we'll set the stage there as to what it has done for the industry, what impact we made, and then also talk about what are the challenges that we've faced and how are those challenges common to different industry sectors, whether it's in the US or whether it's in India or whether other countries. So there are a lot of common factors that are involved in there. So no, it's sort of maybe next slide, please. So, oh, okay, that's even better. I don't know which screen I should look at. Okay, I'll look there. I think it's probably better for me. So, in the interactions I've had with different manufacturers and the audience that I deal with, it's always better for me to set the stage of how I see smart manufacturing as, right? So if you look at this diagram, when you have a conversation with somebody on the street and say, okay, have you heard of smart manufacturing? Or have you heard of Industry 4.0? Or have you heard of machine learning or AI? Everybody has a different perspective on what that means to them, right? If you're a small manufacturer, all it means is, how do I get my data to show up on a screen so I can make decisions? If you talk to a large manufacturer, they'll say, well, how can I do predictive maintenance using AI, right? And there's a huge range. So I said, okay, let's do some stage setting here. So if you look at the bottom left of this diagram, we are always going to start with the manufacturing process that needs to have data extracted from it so you understand what's happening. So the lower left corner of this is what is actually happening. That can only be done by installing sensors, looking at some automation systems. So the manufacturing process icon there could be just a single unit process like a forging press. It could be the entire factory or entire enterprise. So depending on how you look at it. But the key thing there is to get the data out, right? Automation is essential for that. Once you got the data out, now you're kind of figuring out what's happening to the process, what's happening to the manufacturing unit that you're looking at. But that's sometimes not sufficient to take action. So I'll give you an example. If you have uh, a thermostat in the room, you're getting a number, that's a temperature, but unless you know where that is measured, what time of the day, in what environment, in what climate, the information isn't really useful. For controlling the temperature in that room, yes. But if you want to control the temperature of the building and go beyond that, you have to have context. So the second step is all about context to that data. So if you have a manufacturing process that has multiple sensors, multiple products, multiple machines, now you have to set the context to that. That's when you have what we call actionable information. So now you can start taking actions. Now you're going into the area where you now start understanding what is happening. Why is it happening? Right? The why is where the analytics comes in. And then once you've done that, you develop some insights and say, now I understand why things are happening the way they are, but what can I do to improve my ability to predict when that's going to happen? So that's when you start thinking about predictive models, simulations, advanced analytics, machine learning, AI, all that stuff falls on the top right of the picture. And then in the end, what you want to be able to do is bring that back to your manufacturing process. How are you actually going to impact the manufacturing process? It's okay to do machine learning and create a model, but then does it actually do something for your process? That's really where the rubber meets the road. And so this diagram then helps explain what how we tie that back together. Doesn't mean that if you start on the bottom left that you can't improve the process, but the impact is going to be limited. As you go around that curve, the impact goes exponentially high, right? That's the intent of this diagram. The other intent of this diagram is that it's equally critical to understand how information flows from the bottom left to the top right and back. And if you think about information standards, if you think about how technology providers are looking at information that is coming out of your machines and being used for analytics, everybody has their own way of doing things, right? If you have 5 technology vendors that are helping manufacturers, you'll have 5 different ways of doing that. But you need to be able to understand how that information comes out, how it is used, and how it can be standardized. So keep that in mind as we go through the conversation. So anyway, that's more stage setting. So all that is good, but so what, right? So in my mind, you take the ability, the technologies that are involved in that oval that I showed you. You take the information access, information storage, information use pieces, which are basically with platform technology. So you have cloud platforms, you have on-premise platforms, you have all of these things. And I know I'm throwing some technical terms here, so stop me if you don't, uh, if you want to get a little more detail around that. But information flow from your shop floor to the enterprise, and then what actions you take requires platforms. And that's an important piece of smart manufacturing. And the third piece, which is probably the most important, is education. So you go to the manufacturers in your ecosystem and you start talking about Industry 4.0 smart manufacturing, you're going to lose them, right? You have to understand where they are in their maturity, have the conversation, and then bring that out as part of your conversation. When you have those three together on the left hand side, then you start thinking about how do you make an impact on your. I've got 3 words there: performance, productivity, and precision. Performance is your machine performance, right? Your efficiencies of your manufacturing process. Productivity is how much product are you generating per machine, per person in the factory. That becomes your metric. And the third is precision, where you talk about things like quality, right? Those are the 3 areas that it has impact on. How do we make an impact? You do it through simulation, you do it through modeling, you do it through analytics, real-time decisions based on information that you're getting. All of those are things that you can do with smart manufacturing technologies. And by doing that, then you have stuff on the right-hand side where you're improving productivity, quality, reducing waste, improving energy consumption, etc. So this is the basis of how we have uh, created some example solutions, and we've demonstrated that this is possible. So if you look at I'll actually skip this, but this was a study that was done to see what is the potential impact of smart manufacturing on various industries. And you'll probably have this slide with you later on, but you can see the numbers on the right-hand side. This is a pretty significant impact. And these are not numbers shown on a slide. We've actually proven that it's possible, right? So in our world, we've done about 60 of these collaborative projects in the last 7 years as an innovation institute in the US. We've had 55 or so industrial partners that have worked on some of these projects. They've identified problems in manufacturing that can be solved using smart manufacturing technologies. We've touched about 15 industry verticals. Actually, the verticals are behind the slide there. But you can see the range in the impact we made on energy consumption, productivity, and then also the cost of implementing these solutions. If you're a small manufacturer and you go tell them that it's going to take you these many dollars or these many rupees to install this, first question in their mind is going to be, well, is this cost effective for me? If I invest in this, what is the return I'm getting? So you have to make it better for the small manufacturers. The large companies, they have the finances, they have the people, they have the ways to implement that. So one of the things that we've tried to do is to not not focus only on the big manufacturers. So if you look at Honeywells and Raytheons, and these are massive companies that can do stuff on there. They don't need us, right? Who needs us are the small and the medium manufacturers. So we focused on that. So if you look at those numbers, the ranges, the higher numbers are actually from those small manufacturers because little things provide a lot of value to them, right? Um, and then the cost of implementation has to be something that's used. So anyway, so that's the metric part of it. This is a little bit of a complex diagram, but just focus on the oval that I showed you in the middle. This all this says is that we actually have project examples in each part of that oval. So we've done advanced sensing, we've done advanced analytics on the top left, we've done predictive modeling, we've done advanced controls. And if you go to our website, you'll see some examples of how this has been done for the various industries. So, and you can see some of the industry verticals that are shown here. So all this is fine. This is not easy. We've done 60 plus collaborative projects, and we've learned a lot. We've also got you have to be humble. I think when you're running organizations like this, you have to be humble because the manufacturer is going to teach you what's working, what's not working, right? So you have to listen. You have to really spend a lot of time listening. I was telling Dr. Prabhakar here that early in my career, I sat with an operator in the operating pulpit of a machine for 3 weeks nonstop, not doing anything, just listening, seeing how this person is running the machine, what are the kinds of things that he or she hears, what are they seeing, and how are they fixing the problem, right? That knowledge doesn't come from computer systems. That knowledge comes from human beings because they have that experience. So small manufacturers in particular have a tremendous amount of knowledge about their own products, about their own processes. The recommendation is that you have to sit and listen first before you actually act on it. Don't jump to a solution right away. But that also highlights the challenges. So, and this is out of a study from Deloitte, and I just put some statements directly out of them. So the value of smart manufacturing is unquestionable, right? A lot of people have done it. You proved that it works. But getting the workforce to understand how this is done, bringing them up to speed on the types of technologies that you're talking about is a big challenge, right? And a lot of companies need to invest in that, whether you're small, medium, or large, you have to invest in the workforce. And lastly, that there are some foundational things that every manufacturer needs to be thinking about. So it's not about a short-term solution. You take a problem, you fix it, and you're done with it. No. You have to think about how that problem translates into the next problem that you might have, or the system that you're implementing, how is it useful to solve the next problem that you have. So it's more about foundational things. How do you create data foundations? How do you create some playbooks that can be employed by these manufacturers to implement smart manufacturing? So broadly speaking, I've just got a couple of graphics, a couple of slides on this. So culture is a big deal, right? We've come from years and years, decades of manufacturing where it was done by people who I just described, that operator sitting there with 25 years of experience. How do you change the culture of those people to say that, you know what, by looking at information that is coming from sensors and coming from your processes, you can actually do better, right? Question is, how do you change that culture, whether it's the operator, the engineer, the line leader, the upper management? We've actually found that sometimes a dual strategy works better. So top down, you first change the culture at the top level, make sure that the leaders understand this so they can drive that culture through the organization. And then bottoms up, because now you have people who are working hands and feet with the process. They understand it best and they can then help you change the culture, right? So it's a two-sided. Education, the same thing. What are you going to tell engineers and the people who come out of two-year colleges and high schools as to why this is important, right? You have to educate them why this is important. Kids coming out of school these days, they want everything happening here, right? So I'll give you one example. When I worked for Alcoa, we came from the background of, doing things on our paper, doing things on our computers and all that stuff. When we hired new engineers, they didn't want anything to do with laptops. They wanted phones and iPads. Everything has to be in here. How do you make that happen? So part of the education is to rework the way in which your existing workforce works and give them the training, right? Make sure that they're competent with information and data-driven technologies. Technology itself can be a problem. It's also something that you can work with your technology partners to get, right? But it's all about getting the right type of technology to work in the right type of environment. You can't come with an AI solution for a small manufacturer who has two machines. They won't deal with it, right? But if you go to a large manufacturer, then they can start thinking about these kinds of things, right? So the right technology for the right kind of people. And then the ROI is the most important, right? If there's nothing that's going to help them do their job better, nothing that's going to help their product quality improvement, nothing that's going to help them productivity wise, then it's not worth it. And if you give them 1 or 2% increase, they might not like it, right? They might not be incentivized. So the number has to be fair enough and big enough for them to work. So those are some of the challenges we've seen. The other thing is legacy equipment. I mean, the world of Industry 4.0 and smart manufacturing, all that stuff is great, but I would say probably 60 to 70% of manufacturers have equipment that is either 20, 30, 40 years old, and they don't want to invest any more in that. So how do you get legacy equipment to work with modern technologies? That's a challenge. Scaling in cybersecurity. If you if you think about creating a solution that has improved your productivity 25% in a particular operation, how do you take that and scale it and replicate and duplicate it across your other manufacturers and other sites? That's a problem. Cybersecurity is always going to be remaining a problem, but I think there are people who are working on those aspects of it. So, what kind of data needs to be shared to get the benefit out of it, and yet keep your IP within your own organizations. Cost of ownership, it's not just about the implementation cost today, but how you maintain it and sustain it. It becomes a big deal for manufacturers. And then work for upskilling, that always remains a continuous need. We've tried to look at where the biggest needs are in workforce development. It's not just about getting the talent pipeline, so from colleges and universities to help with this journey, but also the existing workforce that needs to be continuously trained because technology is moving so fast that it's impossible for people to stay up with that. I taught a course called Computer Aided Manufacturing at one of the local universities. I taught that for 4 summers. Every year I had to change the content because the technology was moving so fast. Right? The students who graduated the first year were go to the workforce within a year. They have a new set of technologies to deal with. That's a tremendous problem today. Not just in the U.S., everywhere around the world. Um, so what are the opportunities there? I'm speaking to an organization that informs on things like policies. Policy is a big deal. I mean, we've got in the U.S., for example, there are congressional directives that have come out. So the presidential directives are there, congressional directives are there, and they've included in some massive bills that have gone through Congress the phrase smart manufacturing. So it's no longer something foreign to anybody. It's now part of their vocabulary and they understand the importance of something like this. So Industry 4.0 and smart manufacturing is part of the bills. So you can influence the policy. And I think if you do have top-down approach, then you start getting more momentum and that's beginning to happen there. Government funding, again, I was telling her in an earlier conversation that you have to have some seed money, give people some incentive, and that can come from government bodies, whether it's federal, central government, or state government, or even local governments. So that's an important piece. Public-private collaboration for anything to succeed, you have to have that. I mean, any model that I've seen in my 30-plus year career that has been successful because you have those partnerships. Industry, academia, government coming in together and actually working and making things happen. And then the standardization piece is important in today's economy because the world is becoming a playground, and adhering to certain standards that are not just important for your local economies, but also for the global economy is becoming important. You're not going to be playing only in the local area. You're going to be playing, in a global arena. So therefore, that becomes important. So there's some examples in the U.S. where smart manufacturing is part of their policy. There was a National Academies, which is more or less a think tank, but they do a lot of work for the government informing them of policy. So they have a national plan for smart manufacturing, which was the first just a couple of years ago. There's a national strategy for advanced manufacturing, and then there are 3 different bills that have a significant amount of funding associated with smart manufacturing. So that's the manner in which they've made sure that at a national level there's enough momentum in these. And this is also a Deloitte study, and it's kind of hard to see here, but you can see that the elements that make up Industry 4.0 smart manufacturing are actually in that circle on the left-hand chart about advanced analytics and so on. But that's every manufacturer, every company is now thinking along those lines. The leaders are now thinking around those lines, so they're driving that process. And then in terms of investment, there's also significant movement that a significant amount of their budget every year is targeted towards these kinds of technologies. So that's good to see, right? I always end my talk with this because whether I'm talking to technology developers or manufacturers, to emphasize the importance of taking that first step. I spoke to there's a outfit close to where I live. It's called the Digital Foundry, and their job is to encourage small manufacturers to become more savvy in these technologies. And uh, when I've been speaking to them, when you go to them and say, okay, look at what this technology has done for this manufacturer, and it's working very well. Would you like to try this out? We will provide you with an environment, some funding. I say, well, this is not for me. And then we ask them why. I say, oh, it's things, all these things that you're showing us are just too much for us to digest. So we have to then come to their level and say, okay, are you willing to get started? We can show you how to get started in a very small way. See if you like the results, and if you like, move on to the next one. That philosophy has worked well. So the most important thing in any journey, whether it's smart manufacturing, whether it's your personal lifestyle, you're trying to become a better person, first step is always important, right? That's the first step. Second thing is you need to know where you want to be. You can't just take these steps and not know where you're headed, right? So that those are the first 2 steps. And then create a plan. This is how I'm going to get there. And then every moment that you get in celebrating a success, do it. In my former company, we had a philosophy that we celebrate every week anything that good that has happened in that shop floor. And it did wonderful things because people said, okay, we work hard to get all this stuff done, but nobody has time to celebrate. And when you celebrate, then you kind of involve the people in a way that, you kind of take that. And so I've got a phrase called feed the frenzy. People really become excited when they see those kinds of things. So highly encourage those kinds of things to happen. So anyway, those are few slides I want to show to set the stage, but more importantly, I would like to just have a dialogue with all of you and learn a little bit more myself. So.
Thank you, Dr. Malkani. It was quite insightful. So, we as trade economists, we keep working on trade and competitiveness from economic theories perspective. But then it's very good to hear from a practitioner perspective in terms of why is smart manufacturing important and what are the challenges, especially in terms of things like culture and mindset that we never think about. But then even my discussions with the Indian industry, it highlights that mindset and culture is a very important part of, what we take up and to how much extent do we do it. So I have some questions, in mind that probably we can discuss, and then I'll not take much time because I would want to open the floor for Q&A. I'll start first with the research and development. As you have shown that smart manufacturing adoption has resulted in productivity outcomes, better productivity outcomes. But then for that, I feel that a lot of R&D is required. And in India, there's a constant tussle between, whether it's the government's job to incentivize or whether the private sector should be taking it up. So we see that, years after years, government comes up with R&D packages. Even recently, there was one announced by the government, which is called the Research Development and Innovation Scheme. And it has a corpus of around rupees 1 lakh crore. But despite all these schemes and tax incentives that the government has been giving to the private industry, we do not see a lot of action on ground by the private industry, and our share of private investment in R&D as a share of GDP, remains quite low. So, in your experience, like what drives research and development? How do you work with the industry in fostering more R&D? And what's the institutional model, first of all, you follow? So, in your view, what's the role of the government, and to what extent private sector should participate? How much is domestic competition important? Yeah, so the question is actually on the institutional model. The fact that Indian industry is not doing much of R&D remains there. But then what's the institutional model that you have seen in the US that has been working there? And how can we apply those lessons to the Indian context, government and industry roles?
Yeah, it's a very complicated question. So I'll give you some examples of how um, I have personally worked with some industry environments, and then I think from a standpoint of the experiences that we've had as an institute, how that works out. So when I started my career at that point in time, a large company had internal resources to do the R&D in-house, right? We actually had engineers and scientists that were able to do that. Many of the large companies had that. Then in the 90s and 1990s and early 2000s, that trend switched over. What happened is that industry was not willing to do a lot of R&D. They basically said, we're going to subcontract that to the universities, right? So they started giving away the talent that used to do the R&D, put more emphasis on their university partners to do the R&D, right? And then the university partners then said, okay, for us to do the R&D, now we can start leveraging government funding to do that R&D, but with a eye towards what the industry wants. So the model shifted. Instead of doing it themselves, now they're shifting that to academia. Whether that's successful or not, I think that remains to be seen. But what happens as a result of that is that universities will tend to do more early technology development, so early stage R&D. Industry is more interested in more development and engineering and implementation, right? So if they have to drive that side of R&D, they have to take ownership and do it. This model works for large companies. For small companies, it'll never work because they just don't have that I wouldn't say need, but they don't have that immediate return on investment that they would like to see, right? So then they have to be part of a larger ecosystem. So if there's R&D that needs to be done with smaller manufacturers and medium manufacturers, it has to be done at a consortium level. And that then works a little bit better, right? So I think that's probably my view of how that could be successful. I don't know how the uh, R&D structures in countries like India work, but I would have to think that something similar would be better than just putting the burden on one or the other, I think.
But what's the role of the government as compared to the private? So does the government support initially and withdraw, or how does the private? So we have incentives, but then to what extent can government keep giving those incentives? So that's the question, that how uh, how is it sustained? So till what extent, how many years does the government support, and how does the private sector sustain eventually?
Yeah.
Even the
So
projects that you are involved in, so
Yeah.
how are they sustained?
Yeah. So in most cases, I mean, there's a cycle of like 5 to 10 years, depending on which agency is funding it, right? So the National Science Foundation looks at very early stage R&D. So they'll have a time frame of say 10 years. They say we'll fund something for 10 years and then you're on your own to move it to the next level. If it's an institute like ours, it's typically about 5 years. So they'll fund R&D for the first 5 years and they say you have to transition out of there. And then the way we would do it then is to then encourage our industry members to say that, okay, we will do this first 5 years along with you, but anything above and beyond that, then you have to take the burden and move on with it. So the incentives are there in different ways, different forms. And then depending on whether it's early stage or late stage, then the partnerships that take place with academia will change flavors, right? Um, and like I said, I mean, if you're a big company, then you can get involved in every piece of that. But I think for the bulk of it, the government will come in at early stage, institutes will come in at the middle stage, and then the industry will have to pick up the more application oriented R&D.
Right. And coming to the incentives, is there a government scheme that incentivizes R&D there? Because I feel that India needs to do that. For example, we have the production-linked incentive scheme that incentivizes sales. But then had it been on, let's say, value addition, or how much of efficiency are we showing in terms of the production, that can or is likely to facilitate more R&D by the private sector. So all these questions are just to think about why and how can we incentivize and facilitate R&D by the private sector. So are there similar examples in terms of incentivizing the private sector to do more R&D? Because in India, it's again uniquely placed because there's a huge domestic market, and the producers are used to producing the same thing for the same customer. So we are not innovating enough. So in that context, how
I think there are some examples. I mean, the latest example is in microelectronics and semiconductors. So the US basically said that, look here, we've lost that race. Okay, everything is being done outside of US and we don't have anything inside. So they said, how do we bring that back? So there was a massive incentive, huge amount of money there, but that's incentivizing people to do the R&D in microelectronics so that you can reshore the manufacturing in that space. So yes, in a general way, they are incentivizing that. There are also programs where and again, I'm not speaking on behalf of the government, but uh, the different agencies in the government, they come up with their priorities and they say, for us to hit the metrics for this priorities, we will set out this much amount of funding for you to do the R&D in this specific area. So they'll give some of these uh, special sectors will be prioritized, and then they'll make funding available for any size of manufacturer or any academia to come in and say, I'm going to work on this. So there are some examples like that.
So I have two more questions, and I feel that I'll then open the floor for questions. The second one, like this was to do with R&D. So my second question or series of questions is on this changing global ecosystem around standards, certifications, because I have recently done a paper on India's quality control orders that I was telling you about. And it's not only India, but then other countries across the globe they're coming up with these standards and certifications. So and one of the challenges that the Indian industry faces now, either with their importers complying with these regulations, or Indian industry complying with the regulations that their exporters demand, is how do we align the standards and how do we ensure compliance with these standards? So, in what ways smart manufacturing or, the tracking of production processes, maintenance of data can facilitate this, compliance with the regulation and hence improve the cost of production, cost of exports, and even facilitate imports in a way.
Yeah, I think there's a tremendous potential there because, I mean, smart manufacturing is all about information-based decision making, right? So information is critical. And if you think about, we were talking about this in the office, that if you want to track a product, so you're a manufacturer, you created a physical product, and along with that, you're actually giving them a digital file that says, on this digital file is everything that happened to this product from the time it was a piece of raw material to the time that it's a finished product. How valuable is that, right? So then, this concept of a passport or product passport comes in. So, but I think so that's one aspect of it. So you have a digital thread for that particular product, what was done to it, who did it, everything is captured. You may not share all that information, but pieces of that information can be shared with your supply chain, with your customer, and so on, right? So smart manufacturing technologies enable that because the information that goes into those passports is coming out of your sensors and the processing of data that you do, right? Now, once you've done that, now you have the power as a small manufacturer to tell your supply chain customer that, look here, I'm not only giving you my product, but I can actually give you more information that's going to be valuable for you so that you can do your job better. In the aerospace, pharma, these are the places where regulation is really high. So they actually look for that information. We have an example of the food industry, Honey Nut Cheerios, which is a very popular cereal, and we work with that company. For them to take that product, that cereal product, and put it up on a shelf, there's a ton of regulations that they have to deal with. So they had to go back and say, how can smart manufacturing help me get the information right from the point where the oats and the wheat and all that stuff was actually farmed, all the way from there to the point where you have that donut shaped cereal, right? Tremendous. And it's a journey, right? It's not something that happens overnight. There's a lot of investment has to go in for us to get to that point. But yes, I think the potential for smart manufacturing, smart information systems to be part of this regulation based economy is huge. It's absolutely huge.
Yeah, no, definitely. This reminds me of my recent conversation with a small footwear manufacturer. And he was into fashion footwear. And because of these quality control orders that have recently come up. So now he was saying that I can ensure, the way the footwear that I am producing, it should not break and all of these things. But then the thread that I'm using, it's eventually going to be judged and a certification would need to be given on that, but then I'm not responsible for the person who has supplied me the thread. So this in a way would track the
Absolutely.
each stage of the production and would eventually pass on through the supply chain.
Yeah.
And
Yeah.
so yes, but then
Yeah.
because of these quality control orders, the Indian industry is struggling, especially the MSMEs. So, but again, the problem is that even if we give them this solution, then talking to them, training them, and special provisions for MSMEs.
Yeah.
So that becomes important. That how do we, uh, you know, spread this to the lowest
Correct.
segment of the industry. That will become a challenge. But definitely, I feel that even within the domestic manufacturing supply chain and also complying with international standards, the kind of processes that you talked about are quite relevant in this global
Correct.
ecosystem of standards, certifications, and all these rules.
There's also a legal angle to that, right? So if you look at the aerospace industry, when an event happens, right, you always have to think about, is there a way to go back to figuring out what happened for that particular component, right? So, and God forbid, I mean, if an accident happens, then there's investigation, and the investigation says that this particular component failed. Now, if you are the manufacturer of that critical component, then you need to have data to prove that you made it exactly to spec, that something else must have happened. So there's a legal implications as well. So I think these technologies that we're talking about, where you can get the information the right way, right, and get it consistently and get it in a solid way that you don't have, single source of truth. You can show them, and instead of showing a piece of paper, now you have something that's more meaningful that can be shown. So there are multiple angles to that.
Really interesting. I thought of two more questions, but then I'll just stick to one. Then probably I'll open the floor to the questions. So that last one is on the labor question. So I've been working a lot in the labor-intensive manufacturing in the Indian context, and how manufacturing is very important for job creation, employment. So how does this relate to this challenge that India faces of jobs? Would people lose jobs, or would there be more job creation with higher wages? And what does this require? Upskilling of the existing labor force. What are some of the initiatives that your institute has taken to,
Yeah.
what are the skill gaps, I would say, so to upskill the existing labor force?
Yeah.
And how have you been doing it? And lastly, the industry and academia collaboration, how is that important in preparing ourselves for this future?
Okay. Well, I mean, we've been asked this question many, many times, and I think people who are in any of these advanced fields will face that question, right? Um, I think I don't think we can deny the fact that automation and some of the smart manufacturing solutions would take away jobs in a way, right? Because if it's a repetitive task, then obviously automation is going to take that away, right? Uh, this digital passport thing that we talked about, how do you track the information right from the source to the end? If you do it manually, it's going to take you ages to do it. You're accelerating that process. So if by accelerating that process, you're giving that person a different level of thinking. So you're in a way upskilling them, right? So you're not eliminating what they do, but you're giving them tools to make it better, faster, right? Being able to do their work better. So from that standpoint, you're basically increasing the level of competence of your workforce and helping them rise above things that can be done mechanically by a robot, for instance. Is it going to be easy? No, it's not going to be easy, because there's going to be a short-term pain until you get to the point where the entire workforce has moved to the next level, right? That requires vocational training, it requires college education, it requires whatever. Those are all complicated things to think about. In terms of what are the skill gaps, I think I alluded to this earlier on. I think that the thinking has to change, right? So if you're trying to educate somebody on the shop floor about digital technologies, you have to first put it in the context that they understand. So you should maybe start the conversation by saying that, wouldn't it be great if you, instead of looking at that particular product or the process with your eyes and ears and hands and all that stuff, now you have a dashboard that says this is exactly what happened. How does that change your job, right? So the digital skills are important, when they don't have to be in the deep level. You don't need to teach them machine learning, right? That's a different category of people. The new kids who are coming in from high school wanting to go to college, yes, they are all about using Python, right? I don't know Python. I grew up in Fortran. So it's, how do you get to the point where you teach the right skills to the right people in the organization? Not everybody needs to know everything. One of the biggest things that we found was, if you show them as you're teaching, so hands-on teaching and hands-on experience that they get with these tools is always the best way to do it. So the skills that we talk about are more of those cross sections. If you're doing engineering schools and all this stuff, yes, you have to now start teaching them all the modern, programming techniques and AI and all that stuff. That goes without saying. Lastly, about the industry and academia collaboration, in terms of this particular aspect of teaching, it's almost a necessity, right? You can't have training programs and training content developed by academia without a line of sight to what the manufacturer needs. Is going to fail, right? So what we've done as an institute is that we've actually done collaborative projects in education where we've enforced presence of manufacturers while the curriculum is being designed and developed. That way, when it's ready, you have a customer where it goes to. Um, we also have examples of where it's not just the academia and the industry, but the technology partners. So they develop tools and hardware and software that help create this content, so it becomes meaningful for the manufacturers. So yeah, absolutely. I mean, that has to be there.
Right. This industry, academia, and technology partners collaboration, I think, is critical for, for the students to be prepared for the work that they'll take up
Yeah.
in the industry. So great. Now I think we can open the floor to the questions. So anyone?
Back there. Oh,
It's Dr. Mo.
3 hands.
Thank you. Thank you very much for a very fascinating exposition of what's going on in industry of manufacturing 4.0. I have three quick, somewhat unrelated, but also related questions. One, what is China far ahead in smart manufacturing? And how have they, if that is the case, how have they managed it in terms of what is happening in universities and how they connect universities and research institutions to industry? Two, with the attack by Trump on the National Science Foundation, all scientific institutions, scientific funding, top universities, is this whole activity going to suffer? Or he's not attacking this part? Third, somewhat different, something that's been puzzling me for more than 15 years actually is that all the productivity calculations and estimates done by economists suggest that productivity has slowed down in the last 25 years relative to the previous 25. It's puzzled me no end because I know that every machine now has some IT embedded. In our own work, what we see as economists, we do far more compared to what I did when I was a PhD student, when you had to wait overnight at a computer center university to get in results out. But the economic research does not show any. In fact, it shows productivity slow down. So this has been a big puzzle. And also, I've been sort of associated with McKinsey Global Institute, and they tried very hard because they are sort of IT nuts in a sense. They tried very hard and they also couldn't find it actually.
Let me respond quickly. Whether China is ahead in this, I think the simple answer is yes, because they've been able to pump a lot more money in a very concentrated fashion towards these kinds of things. So the amount of money that is going into R&D, the amount of money that's going into helping the industry create and implement some of these technologies, it's really, really huge, right? So so in the US, we had, smart manufacturing became a thing about 15 years ago. And it's taken us that much time to reach that maturity now where there's enough momentum that we don't have to justify it. People want it, right? China got there really, really fast, right? And because of the level of investment. Germany has done the same thing through, multiple ways. So yes, and the answer is yes there. I look at the same data that you have. It puzzles me as well as to why, because one would think that with all kinds of stuff that's going on in the technology, why isn't the productivity improving? You are all experts in that. I'm not. So I don't know. Maybe that's a lecture that I can listen to someday. But I'll leave it at that. Yeah. Yeah.
Yes, basic question that I want to know about your views regarding as far as over investment in smart manufacturing, artificial intelligence is concerned, because it is considered that it basically suits very few big monopolies or few big geographies like China, etc. Which have got the materials or which have got the intellectual property as such, and can't basically eradicate all the problems of the world, and still we are over investing in these technologies, because I mean every 6 months, every week new agent AI basically gets developed, by these large companies like Salesforce, etc., Microsoft, etc., and basically which basically leads to you have to purchase new application, you have to purchase new software, you have to, purchase new device, etc., which is a lot more capital intensive as far as a lot more, many firms are concerned. And secondly, as far as even the semiconductor manufacturing also is concerned, still, companies basically, countries basically still will need a lot of energy, a lot of space for that, a lot of new materials, for example, like graphene, etc., which something, which basically a lot of these countries are not well equipped, to, deal with, at this point of time, because they simply lack that kind of resources, So how do you see these innovations basically working for very few vested groups, and vested interests here? So
Yeah. I mean, I think, it's pretty clear that AI is pretty powerful, right? And my advice to people is that you have to put it in context of that use case. So, for example, if you're looking at information from retail, right? You have information coming in standard ways across multiple uh, uh, retail outlets or whatever it is, right? To run AI models on that is a pretty effective way of analyzing data, large amounts of data, and all that stuff that humans cannot. My previous example of going to a small manufacturer and saying that AI will be useful for you is going to fall flat, because they can't make the connection between a person sitting there running a lathe, creating a metal cylinder that's going to end up in some automotive application, right? How does AI help me? So you're exactly right that AI in manufacturing is going to be useful immediately only for the large manufacturers who have the kind of operations, the kind of data, the kind of global reach, et cetera, to do the analysis and benefit from it, right? But having said that, AI can only be useful as the data that it receives it, right? So the number of operations, the diversity in operations, the more diverse it is, the better the AI model is going to be. So we are always telling people that if you can collaborate and create AI models for that particular industry sector, you'll be better off than going it on your own, right? So there are these kinds of conversations that take place, but you're exactly right. It's going to be useful for a small sector of the population, small segment of the population. But these tools are being generated in a way that you can take 80% of what's being developed in one use case and at least have the mathematical formulations and the core be useful in other use cases. But for that, you need human intelligence, right? I always use the phrase augmented intelligence because AI by itself is not going to be useful. You have to have the human ability to understand the context to make sure that it's actually doing the kinds of things that you want it to do. But again, the topic of AI is going to take you can spend 5 days just talking about it. So thank you for bringing that question up.
So 2 questions, Haresh. And this follows up on Rakesh's question about what the US will end up maybe in 5-10 years with the trend that we are seeing now. What's puzzling about that experience, and it therefore has lessons for countries like ours, despite the destruction of the entire ecosystem that has led to the kind of innovations which we've seen coming out from the US over the last 50 years. Despite that destruction and the breaking of the partnership between the universities, the government bodies, whether it's the Department of Energy or a whole range of others, and then industry, despite the destruction of that partnership that we are seeing in real life and on an ongoing basis, you don't see the protest from industry. The industry, despite being very powerful politically, and I'm thinking of Silicon Valley, but all over the place, you're not seeing the pushback from that important member of that partnership. What explains that? Because that has lessons for other countries as well. And then from that, a broader question: how does the structure of industry, whether it's competitive, whether it's monopolistic, whether there are just 5 large players and then a whole host of small ones, how does that impact the kind of ecosystem that you've been so integral in building up in a very advanced economy? Because there again, there are reflections in our country with some very large manufacturers with large international reach, and then a whole host of very small, informal almost enterprises. So
Yeah.
be very useful to get your views on those.
Yeah, so to your first point, I mean, so my personal experience there has been that, companies are gauged on their ability to make profit every quarter, right? So the short-term thinking has driven them to say that if something can be bought, we are not going to do it ourselves. R&D falls into that category. So that's why I mentioned what I mentioned earlier on, that they now are okay and comfortable with creating R&D contracts with universities and say, okay, we are not going to do it. You do it for us. We're going to tell you what to do, right? And they become comfortable because in their revenue model, that becomes more manageable rather than saying that I'm going to maintain a staff of 15 researchers and do it internally, right? So that's a comfort level kind of thing. To your second
Follow up, but we're seeing the destruction of that very comfort that's going to happen, right? The patents that have come out from the largest universities on the West Coast, on the East Coast, those are going to start dropping in the sense that the funding is gone,
Right.
and these universities are being attacked on the grounds.
Correct.
So indeed, that comfort is exactly what should now be discomforted. And
You're
these
exactly right.
companies are, you don't see any protest whatsoever. And that kind of goes to the politics of this as well. But in a country like ours, that's very important to understand.
To your second point about whether it's a industry sector that has a few companies versus large companies, what seems to work. I think it's a mixed thing. I mean, we've seen both. In the case of semiconductors, we've actually worked with one company that has brought together about 11 manufacturers together. And they've decided that, yes, that's the best thing for them, because to my earlier point, that if you develop AI models that work in predicting a certain aspect of your manufacturing operations in chip making, that the more diverse data you have, the better that model is going to be. So they understood that and they came back, right? But 10, 11 is one comfortable number. If you look at food manufacturing, you've got hundreds of thousands of manufacturers. To bring them together to think that way is going to be a huge deal. So we have to say that, okay, you have to, bite what you can chew, but show it in small sectors and say, okay, well, we've shown an example of how this can be done. Perhaps industry can wake up and say that, yes, we can take this on, right? And then we have to partner with industry coalitions. So, like Society of Food Manufacturers or whatever that happens to be, then they become an important part of that ecosystem to help that happen.
So I just want to take a view. What's your view on this? That government is taking a lot of interventions for manufacturing. So different schemes in different sector. Still the growth, the share of manufacturing, it is somewhere between 16 to 18%.
Okay.
So what is it that is not just driving the manufacturing sector? The big push that is needed, it's not coming even if, government is intervening in terms of schemes, R&D, PLI scheme, but still manufacturing growth is not taking place. So what's your view?
I mean, we've seen that in the US as well. I mean, it's just difficult. So there's probably a couple of things that come to mind. One is that one big conversation we had was that it has to start with painting a different picture for manufacturing. Right? Manufacturing has always been considered to be a job where, it's I think there are like 5 different Ds, like dirty, I don't know, dirty, dangerous, stuff like that. That's what's associated with manufacturing. Modern manufacturing is none of that, right? You go to a manufacturing floor today in a reasonably well equipped operation, and Anup can tell you that it's far from those things. So if you're taking your children to work, if you're talking to people in high school, you have to start that conversation by saying that manufacturing is actually exciting. Okay, I'm going to use this word, maybe it's not appropriate, but manufacturing is sexy. But people today are saying, or analytics, big data and machine learning, that's what's sexy. No, manufacturing can be sexy if you give it the right context. So that's where it has to begin, right? Secondly, manufacturers will always face, I know we are running out of time, but manufacturers will always face this question around what is the ROI? I mean, if they think that by making this product better, they will actually increase their revenue, their growth, and all that stuff, then they will manufacture. But somebody has to make that obvious to them, right? So.
We'll take two more questions, and because we are already out of time. Karthik.
Hi, Harish, thank you for your presentation. I had I had questions specific to American policy, which is the IRA. Wanted to understand what really worked in terms of supporting green technology manufacturing through IRA. What is so unique you think that worked very well when it came to IRA and green technology manufacturing? And secondly, where do you see the future of IRA in the Trump regime and moving forward? Thank you.
Well, I think that sort of borders on a political comment, so I will refrain from that. But what I'll say is that in general, the IRA brought enough incentives, I think, for the clean energy industries to flourish, right? There were incentives given. There were some funding mechanisms that came through. Were they all successful? Probably not, right? There were pockets that you can have examples that say, okay, this failed or this worked. But in general, it raised the awareness of manufacturers to say that this is the right thing to do because there are consequences if you don't do it, right? So I've personally seen there are examples where that has happened, right? But in general, I think some of these congressional measures that were taken were beneficial for manufacturers to realize that it's an important piece of the puzzle. That
Yeah, please go ahead. Please introduce yourself.
Hi, I'm Kunal Tyagi. I am a public policy professional from Koan Advisory, Delhi. So I had two questions on which I'd like your thoughts. First is in the beginning when you was right in the beginning when you said that smart manufacturing means something different for a small manufacturer, something else altogether for a big manufacturer. So in India, and you gave the example of how for a small manufacturer it would be something perhaps as simple as getting the data to show up on the screen. And smart manufacturing is perhaps a step ahead of what the government has been trying to do for MSMEs in India, which is digitalization essentially. And we've been lacking on that front as well. And I don't know, last week there was an article on Business Standard, which basically said that 70 to 80% of the MSMEs have not benefited from any of the training schemes or training initiatives that the government has started. At this stage, what kind of training efforts or initiatives do you think could work or you have seen them work? This is one of the questions. The second question was, like Dr. Prabhakar also said, that job creation is a priority for this government, leveraging all that demographic dividend and all of these things. Consider, for example, that we have, for example, textiles industry, which has been a historically important sector, and we're a export a hub for that, so to speak. We have competitors as well. But on the other hand, electronic sector is one which has been emerging under the PLI schemes and all those other initiatives. Now, textiles perhaps is more of a, it's very fragmented. It's you have cottage level or very small level firms or manufacturing units. Whereas in electronics, we have large assembly lines perhaps. And consider the example, consider the case of the latest ECMS scheme, the Electronics Component Manufacturing Scheme, wherein part of the incentive is being awarded for the employment generation aspect, wherein you're not just being awarded incentives for capex or for your sales, but also how many jobs you generate. And one of the point of frictions that actually kept the discussions ongoing for months was that the electronics sector in the industry basically claimed that the sector has a significant level of automation. And for, let's say, per piece of PCB that is being made, we can only put 2 people together there. And the government insisted on let it be 3 or 4 or something along those lines. Considering this context, which industries do you think are at the forefront of being able to optimize smart manufacturing to the highest degree in the Indian context? And we can confidently say, perhaps, or rather, to some degree, wherein the return on investments or the economic gains would be able to offset the job losses that could potentially take place. Thank you very much.
Well, I think the first one is probably something that I can answer quickly. The second one requires a lot of discussion. But I think the kind of training programs that are effective would, we have a statement that, you have to meet the manufacturers where they are, right? So my earlier comment about listening to them, what are their needs? What do they need to understand? Not just have a blanket training program that's one size fits all. That'll never work. You have to customize. So you have to put in a lot of effort in customizing, but not to the extent where every program is just unique. Then it's sort of wasteful, right? So you have to take some common elements, like I was talking about, how do you make them aware of what digital technologies do? You just take an example of 2 or 3 different manufacturers and say, what is common in the 3 in terms of understanding what digitalization means, right? And how it can help them. And then start there and then create that training for that level. High schools and early college and all this stuff, that's another segment of the population where you have to think about, how do you do that? We've done things where we've introduced smart manufacturing concepts in existing frameworks. So if you're doing electrical engineering, mechanical engineering, or 2-year college, where do those things get inserted, right? Those have been successful rather than trying a brand new program, right? So there are some things that can be done to make it more effective, but it's very, very, it tends to be localized. So we worked with small colleges, small universities that are regional, local. They understand their manufacturers. They understand their ecosystem. Those have been effective. If you go at a large scale, one size fits all, that's usually not what I would recommend. I think this job growth thing, and maybe we'll punt that one because it's a difficult problem. It's a difficult problem, and in many cases, you can probably identify industry sectors where it'll work well or not. To your point, right? I mean, if it's I'm going to avoid anecdotes, but there are examples where you can have you can show that for this particular industry sector, for this particular type of manufacturing operation, you can eliminate jobs completely, right? But then there's a flip side, like in textile or in products that are not mass produced, you probably have more content there for human involvement, right? So I think those would then define where you would have more effective ways of bringing in the balance.
Thank you, Dr. Malkani. And if there are any more questions, we can take them outside, offline. Thank you so much, Dr. Malkani. I feel that there was a question about why is not much manufacturing happening in India, and one of the reasons that I have found in my research is productivity. And I think this form of manufacturing gives an opportunity for productivity enhancement, provided we are able to grab the opportunity and overcome the challenges. So yeah, it was very insightful to hear about your views and what CESMII has done. So thank you so much.
Thank you. It's a pleasure to be here.
Thanks, everyone.